Good morning. Welcome, my digital histology trailblazers. We are live on a live stream that's going to be about histology of three important organs. Well, I think all organs are important. Well, maybe some are less because you can take them out and you can still live. But we're going to be talking about the eye, we're going to be talking about the skin and palatine tonsils. And for those who are joining me for the first time, I'm Dr. Alex Zhurav. I am a veterinary pathologist and a very strong digital pathology enthusiast. And in this live stream series, we're going to be talking about histology, about the normal, so that whenever you need to recognize abnormal, you know what the baseline is. So whenever you are joining me, let me know where you're tuning in from. I see you showing up already. So just give me a comment because I need to see also if the comments are coming through. Sometimes these streaming platforms are not cooperating last week. But if you're here live, let me know in the chat that you're live and where you're tuning in from. And if you're watching the replay, let me know that you're watching the replay. And you can see on this screen, let's see if I can show you stuff here. Test. Okay, it's working, but a little difficult. Okay, so I'm going to start with something else than because we're going to be working with digital slides. So I want to show you the digital slide workflow first. So let me change the screen that I'm sharing with you. And it should show digital slide workflow now. Okay, I have a participant live from France. Amazing, amazing. Welcome, Eva. So amazing. So, before we dive into the histology, digital slide workflow, and it's actually any slide workflow. Microscopy, those digital slides are created from microscopic slide, from a glass slide, right, that you would look at under the microscope, but they're now digitized and I can teach them online, right, without having the microscope. And there is a certain way of looking at slides both digitally and non-digitally. And if you're joining in, let me know where you're tuning in from. And my drawing, there's a magnification strategy, right? You start with the low level. At 4x is just an example. It can be a lot less than 4x, and we're going to see that for the eye to have the overview of the full organ, you need to go a lot lower than 4x, like 1x, or on the digital slides you can even go 0.5x, and you can use it for orientation. That's going to be super evident when we will be talking at skin, and then find example landmarks. We're going to be finding all of them. Then you go to medium magnification, which I would say is rather like 5 to 10 would be medium. And then you're going to be seeing the different layers. We're going to be discussing cornea versus sclera collagen. You're going to be able to see like not yet, probably already cellular level, but not yet cellular details. And then high magnification, 40x plus, depending on what your objective is, or what your digital zoom is, you can see the cellular details. And this is where we're going to be looking at all the different structures. Good news for you. This is basically what I'm showing you is part of a note file. We have notes for this. We have the link to the slides that we're going to be describing. It's currently on Path Presenter. Shout out to Path Presenter, the platform that's making this teaching available. And if you want the notes, just give me a comment in the chat, notes, because I don't have them set up yet for download. I cannot like give you a link. I'm going to be giving some links for other stuff, but for this you would need to comment that you want it, and I'm going to reach out to you for the next live stream. We're going to have it all set up. And now let's go to the eye. That's it. Okay, just something went into my eye. Perfect timing. Anyway, so this is the eye. And you can see it's round. And it have different parts. I love how it is explained because we have in the big pictures we have big picture we have like three different tunics, three different layers of the eye. We have the fibrous tunic, the vascular tunic, and the neural tunic, and they go basically from the outside. Something's happening to my pen. Sorry, guys. Why are you doing this to me? Come on. Okay, from the outside to the inside. This is going to be our neural, nervous tunic. So this is fibrous. I cannot stand it, guys. I wanted to write. Why not? I cannot live with that. Sorry. Okay, I'm getting some yeses, but I will not know what a yes is in the comments. So if you want the notes, write notes, the word notes in the comment. And also just say hi and let me know where you're tuning in from. So from the outside to the inside, we have the fibers, then we have the vascular, and we have the neural tunic. And the key roles of these tunics are going to be for the fibrous one is going to be protection and shape. So that's going to be the stuff that's going to maybe I could do annotations here. It's going to be better. Yeah. Okay. I'll try that. So the fibrous is going to be protection and also giving this eye a shape, this round shape. Here we have like a little bit of an angle. This is going to be the fibrous tunic roll. And then, so let's look at it. This is our cornea. And we're going to be diving into it, but I just want to show you that, okay, this is the protection from the outside. It has to be protected. Other than my glasses, I need to have some more protection. It has to be nourished. So for nourishment, we're going to have the vascular level where there are going to be vessels. But the main role, okay, I'm getting some notes comments. So if you guys want the notes, let me know. I'm going to send you the notes. And then the main role or the main goal of the eye is to see, right? So we have to have the neural connection to the brain, and this is what we have right here on the back of the eye. And it actually like goes out to the brain because this is our optic nerve. I'm going to be trying to write a little bit, but may not work. Okay, so starting with the fibrous tissue from the very beginning, from the very front, we have the cornea. I so want to write for you. I'm so sorry, guys. And if you have any questions during the live stream, you let me know. I'm going to be showing them on the screen and answering. But cornea. Cornea has a couple of layers, as you can see here. So when we already went, I'm gonna get this out. Okay, we can go even like super high. Well, 100x. We can see everything here. But let's do this and see the structures that we have here. You can clearly see here. I need better annotation tools, guys. Maybe this is gonna work. This here. I'll see. Not necessarily. I'm gonna change the color and I'm just gonna be making dots. How about we try that? Dot, dot, and dot, more or less. Okay, so the first dot is near the uh, corneal epithelium, and corneal epithelium is has also called Bowman's epithelium, has a membrane. Here's the membrane. I don't know why it's doing this. And here is this epithelium. And this is stratified epithelium. This is squamous. These are squamous cell. This is a squamous barrier, and the every epithelium is laying on a membrane. Here, and it's not that well visible, but can we go even higher? Yes, the membrane would be here. This is what it would be. Every epithelium sits on it, and this particular epithelium is called Bowman's epithelium. And then we have a bunch of these pink fibers. This is collagen and fibroblasts arranged in a specific way, a very parallel way that lets the light go through. And this is the it's transparent, and this part of the eye also has a membrane. It's called Descemet's membrane. It is simple squamous epithelium, and this Descemet's membrane pumps the fluid out. It has to stay transparent. If there is too much fluid, it's going to get cloudy. We don't want that. And I see new people joining. So there are going to be notes from this class, from this live stream. So if you want notes, go ahead and put the word notes in the comments and just let me know where you're dialing in from. So this membrane here, this super thin one, something's happening with my annotations today. It's called Descemet's membrane, and this is our endothelium because it's the internal epithelium. So this is our cornea, and then cornea has like a sister or continuation that also belongs to this fibrous layer that extends all around the eye here, and this is called sclera. You can see that in the sclera, you also have these fibers, but they're kind of denser. I don't really know if we can appreciate it microscopically. I see that these are a lot more regular, but the difference is that this is not transparent anymore. In the sclera, the fibrous tissue is not transparent, whereas in the cornea it is. So you can see through it. And in the sclera, you cannot see through it. So, and then they have this part where they join. This is the transition here, right here. This would be our cornea, and this is our sclera. And this transition from one to the other is called limbus. We have the ordered collagen, and this is supposed to be a little bit less ordered. Honestly, to me, it's ordered as well. But maybe somehow it is not. But obviously, we have other stuff here on this limbus, on this border. We have all this stuff. And this particular thing is iris. And this thing here is ciliary body. Here, no, actually, it extends here. Ciliary body with ciliary processes. And let me show it to you from a little bit more of a distance. You can see all these landmarks at low magnification. It's telling us it's 0. I don't think this is accurate. Maybe it is accurate. Zero magnification, that's true. Come on, what's going on? What did we do? Oh, do you see this little thumbnail? Actually, you cannot see it, but I'll show you in a different way. No. Anyway, on the left here, you can see part of it is a little thumbnail. So to go somewhere specific, you can just click on this thumbnail. And this is something typical for digital slides. You usually have this little thumbnail where you can click and it's going to take you to a different part of the slide. But what we were talking about was this limbus, and we are transitioning from the fibrous to the vascular tunic. Here, this is going to be part of the vascular tunic, and vascular tunic is supposed to nourish the eye, is supposed to give implants. If anybody wants notes from the class, there's going to be notes from eye, skin, and tonsil. Let me know in the chat that you would like to have the notes. Just put the word notes and I'm going to send it to you. And let's go to the vascular tunic. First, iris. You can see that there's space in between these two flaps, these two pieces of the iris. And we have the anterior border of the iris and the posterior epithelium. So let me show it to you from closer. This is the anterior and side, and this is the posterior side, and we're going to be talking about what's there as well. But it's dark. You can see that it's dark. It's melanin rich. It's pigmented, right? And we're going to be talking about this pigmented epithelium. It extends also to the ciliary body, all the stuff that is dark. And it's called retinal pigmented epithelium. I mean, it's continuous with the retinal pigmented epithelium, and it's going to go all the way to the back, to the retina, and that is our layer that's going to accept light and translate light into what we see in the eye. But going back to the iris, the iris is going to be the thing that gives the color to your eye. I'm going to answer some comments. And so you can see this gap here. We saw this gap already, and it regulates how much light is going into the eye. This is the function of the iris, to either let a lot of light in or let a little bit light in. And we have our ciliary body here. And it also has this dark epithelium, the pigmented epithelium. We have processes of the ciliary body right here. Ciliary body processes. And we have some smooth muscles, and the function of this is controlling the shape of the lens. So this is going to be attached to the lens, and this is the lens, actually. All this is the lens. Let me know in the comments where you're tuning in from. And the lens focuses light into the retina, and and it needs to be clear. And if it's not clear, then we have blurry vision. But basically, the ciliary body attaches to the lens and regulates its shape for focusing, for being able to see. Mm. Our next part. So we have also the choroid, which is the vascular layer of the eye. And here, it's gonna be nourishing the eye. And I would love to show you like vessels that have blood in them, but I don't see blood. But I see the vessels. Mm-hmm. Okay, so here they're nourishing the eye. Let's go to the back and look at the neural tunic. The neural tunic is on the back, gets light, and translates it into images in the brain. And the main part of this neural tunic is the retina. Here, this is the retina. You can distinguish several different layers of the retina. And I mean, I have a table in the notes about all these layers. Let me show them. Let me show the table to you. Honestly, you probably, if you have like an exam or something, um, you will need to learn them, but I never had to actually, like in real life, talk about them. So, like from the histology standpoint, you can have the RPE, the retinal pigmented epithelium. So this is going to be the thing here. Sorry. Can I share two screens? No. I cannot. Retinal pigmented epithelium, photoreceptor layer, external limiting membrane, outer nuclear layer, outer plexiform layer, inner nuclear layer, inner plexiform layer, ganglion cell layer, nerve fiber layer, and internal limiting membrane. So a lot of membranes, I have to say. And now let's look at them on the image itself. Okay, so we're starting from the retinal pigmented epithelium that we already showed that goes like all around the eye. Here are my limiting annotation capabilities. So all this dark thing going around the eye is our retinal pigmented epithelium, also abbreviated as RPE. And this is where we are going to be counting the layers from. So let's see if I can even count 10. We have the RP 1, 2, 3, 4, 5, 6, 7. Okay, I see 7. So, but there are like membranes. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these membranes count as well. So yeah, I guess I need to do a separate live stream on retina and go super deep in. But you can see what we have here. So we have the retinal. Let's see if I can make dots here. Retinal pigmented epithelium. And then we have rods and cones in the photoreceptor layer. And then we have the membrane, we have the outer nuclear layer. So these nuclei is the outer nuclear layer. Then we have outer plexiform layer, inner nuclear layer. So these are like super visible from the outside. uh, inner plexiform layer and ganglion cell layer, and they all have different functions. But the signals going to the brain go through here, through optic nerve. This is optic nerve, and it goes to the brain. And that was our eye. Let me know if you are interested in the notes from this with all the layers of the retinal epithelium and everything we discussed on the eye. And now, and also let me know where you're tuning in from. Now we're going to go to skin. And also what I wanted to tell you that in those notes, you're going to have the link to this particular slide. The platform we're working with right now is Path Presenter. So big shout out to them for making this available. This is free. You can basically access these slides. Let's see if I can just share this in the comments. Let me know. Check if this link is working for you. I hope you can see my comments. And let me know if you can click on this comment and get to the eye slide, and just let me know in the comments that it worked. And we are gonna move to skin. This is skin, also from Path Presenter. And again, we have the big picture. We have 3 layers in the skin. We have the epidermis, dermis, and hypodermis. How can we recognize them from far away? So, and as always, we start from low magnification to high magnification. And the link is to one of the slides is in the comments. So let me know if you can open it. And you can already see that this here is like a lot darker. This is like certain shade of pink here, and different type of pink, and like a lot looser here, right? So we have these 3 different layers, right? That's what they're called actually officially. And again, and this is the outside going to the inside of the body. So from the outside, we always have something that protects us. This is the barrier. This is the thing that is going to be keeping germs, keeping stuff from going into the body. So let's have a look. Let's have a closer look from the outside to the inside. And this is our epidermis. All this dark part. An epidermis consists, this is our barrier. This goes from the base of this epidermis. The base is there's always at the base, there's a membrane, right? So there's going to be a basal membrane, and going to the outside, we're going to have this keratin layer, a layer of dying/dead cells that constitute an additional protection layer. This is going to be stratum corneum. And then in the inside, going more to the inside, we're going to have dermis. And then we're going to have something called hypodermis, where we will see some fat tissue. That's going to be fat tissue, some glands. Glands are going to be in the dermis as well, but hypodermis is under the skin. It gives us insulation, and it attaches to the rest of the body. So looking at the epidermis, we also have different layers, and they are called stratums. And going, and we always describe, I don't know if always, but I will describe them to you. Oh, and I see more people joining. So give me a comment where you're tuning in from. And also if you would like to have the notes from this particular live stream. So here we're going to be talking about the layers of this epidermis. And similar to how we did for the retina, I'm going to show you the layers first on screen, so that what's going on here? Okay, let me share a different screen. On the epidermis. Okay, we have different layers. They are called stratums, and here are their key features. So from the bottom, actually, it's stratum basale, the base. Then we have stratum spinosum, granulosum, lucidum, and corneum. Corneum is the flaky stuff that I showed you. Now let's go back to the slide and let's see if we can find them. Starting from stratum basale, also known as germinativum. These are, they should be, or often you can see that they are arranged in a little bit different fashion. They're cuboidal, like they should be lined a little bit like a row. And what we should see there are mitosis, because this is something that is regenerating the skin. This is where the cells are growing. This is where they are proliferating, dividing, so that we can have all this protection layer. I don't see any mitosis. Maybe later when you guys look at the slide. And by the way, if you do you see my comment with the link? Let me know if you see the comment. Because maybe you just don't see it and I'm asking you, oh, can you click, and you just don't see my comments. It sometimes happens. So here you can see very much appreciate that this is columnar fashion. They are like row of columns. So we're gonna also have melanocytes here with that are from a different origin. This is a cell of a different origin. It's not epithelial cells, but they come here and they give pigment. They come from the actually they are a neural origin, so nervous tissue origin. They come and give the skin the pigment. So when you tan, you get darker because the melanin granules and melanocytes migrate to the top of the skin. Then stratum spinosum are these spiny cells. Let's see if we actually see any spiny cells. Often with these like descriptions of different layers, you're not gonna have them very literally depicted in every slide. So I always take the appearance as like the most perfect appearance, but I want to find some cells that are like spiny. Here, maybe this one is spiny. Well, it's triangular, so I wouldn't say it's spiny. But basically, above our stratum granulosum, we're supposed to have stratum spinosum, where these cells are a little bit like have some projections. And then we have stratum granulosum, because it has granules, and the granules are keratohyalin granules, and we should see them. I'm like disappointing you so much because we don't see them. But the stratum granulosum is going to be like 3 to 5 layers of cells. So do we have 3? 1, 2, 3, more or less. 1, 2, 3. So it would be the thickness. That would be it. I don't see so many granules. If I find any, I'll show them to you for sure. Trying to find some for you. Maybe if we would go to a higher magnification, but for this one we can only do 20x. Okay, I don't see that anybody is seeing the link, so maybe you just don't see it. If you see at some point, click on it and let me know if you can see the slide. And in the meantime, let me know if you want the notes. Moving on. Stratum lucidum is something that is only going to be visible in thick skin, and this is actually thin skin. So we don't have the stratum lucidum that should be at the top, but we do have stratum corneum, which are all these flakes. This is stratum corneum. This is actually these cells here that were here. Here you can see them already like flattening, that detached and lost the nucleus and became these keratin flakes that additionally protect us from damage, protect us from whatever is happening to us from the outside. We need some protection. And now we go deeper into the dermis. And dermis actually starts already here with these. Let's say this is our basement membrane, what I'm drawing right now. On this side of the basement membrane, on the bottom side of the basement membrane, is our dermis. On the top side of the basement membrane is epidermis. So now we're looking into dermis. And dermis has also different parts. So these projections look a little bit like fingers, and they are called that's why this is called, this dermis here, right here inside, is called papillary dermis, and this are dermal papillae that are integrating with the epidermis. So they like intertwine so that they stay together. And this is made out of collagen, different types of collagen, 1 and 3. And it also has already some nerves and vessels, and we're going to look at nerves and vessels a little bit deeper later. And this is called papillary dermis, whereas the looser dermis is called reticular dermis, and it's irregular, dense, and this is connective tissue that is composed of type 1 collagen. And we're going to find hair follicles if there is hair. I don't know, we don't have any hair here. Maybe that was supposed to be, I don't think so. But we're going to find also glands, eccrine glands, and apocrine sweat glands, and we're going to find maybe some corpuscles, some neural Ruffini and Pacinian corpuscles. Actually, I have not seen them, but they should be there. But we will find nerves. So, for example, this could be a nerve. Yeah, I think it's a nerve. That's what we're going to find in the dermis. So let's see what we can see here. Okay, this looks like a nerve. This is a vessel. This is a vessel. And this round one looks like an artery. This one looks to me like a vein. Let's see if we can see any other structures. This is a nerve as well. And here are vessels. A little bit difficult to see, but what I'm drawing around has a lumen. Now I'm drawing in the lumen, and this is a vessel. Looks like a vein. The arteries are always like a lot rounder and look firmer, and veins get flattened. Here we have a bunch of glands. And on the side, so usually, let's see if in the other part we can see it on the top or the bottom. Yes. And now under the dermis is a so-called hypodermis, also known as subcutaneous tissue, and this is fat, adipose lobules, so fat separated by septa, and we have also blood vessels and nerves there. I am not seeing any Pacinian corpuscles. These are very typical, like onion-like looking receptors for pressure, but I do see fat cells. So these are classical adipose fat cells. Fat, and all these guys are fat cells that in life are filled with fat, but when you process the slide for histology, you actually make them empty because you dissolve the fat. But this is where it was. And it's a little bit squished here and here, but definitely adipose tissue. And I think that's it for the skin. If you have any questions, let me know in the chat if there's anything you would like me to show you. Oh, this one has also a bunch of glands. Oh, we have a hair follicle. Look, this is a hair follicle. Yes. This inside is hair with keratin. And it's like this unit. It's called hair follicle unit. Oh, this is like another one. This is number one, and number two. And this unit is going to have uh, the hair bulb, and it's also going to have associated sebaceous glands. I don't see them. But yeah, here, these cells are basically epidermal cells. This is the hair bulb, and this is the hair here inside. And when I find a bare hair for you, I'm gonna make a histology video just on a hair follicle. For this one, I'm just gonna leave you with that this is a hair follicle. Anything else interesting? No, we're good. Okay. And now I'm gonna leave this one in the comment as well, in case it actually goes through. Another one, and I see new people joining. So let me know where you're joining in from. I see people coming and going. That's totally fine. Just whenever you join, let me know if you can hear me well, see me well, and where you're tuning in from. If you're watching live or if you're watching the live stream. And we're on our third organ right now. It's the tonsil, palatine tonsil. And there's one structure that will help us recognize that this is from the palate. These are the tonsils that kids get removed when they get too big and like get infected all the time. And the structure that is gonna help us recognize that this is from the palate is actually epithelium. Because oh, why is it not okay? All good, all good. Because most of this tissue, you can see that it's like pretty homogeneous from far away, dark, and when you go in, a lot of dark dots. These are lymphocytes. These are immune cells that sit there to protect us from outside danger, from pathogens, from mostly from pathogens, but also to present antigens from everything that's entering our system from the outside. These cells are gonna defend us. But what we have here is this epithelium and the palatine tonsil. We have also pharyngeal tonsil and tonsils on the tongue, so lingual or tongue tonsil. And they will not have this epithelium, and it looks so cool. And you can see that we have a similar structure to what we had on skin, because it is actually skin, but it's a mucous membrane of the inside of your palate, right? And you can see very similar structures to what we had in the skin. We had this basal structure. We had the papilla from the dermis going in. So, and we have people joining live from Lagos, Nigeria. Amazing. Thank you so much for joining. Let me know if you can click on any of the links above. Above your comment, there should be two links. If you see them, let me know if you can click. And if you don't see them, let me know that you don't see them. So we're kind of coming in from the outside, from our palate, from our mouth. And then we get into these lymphoid cells. From far away, you can see that these are these round structures, right? These little circles are here, and these are lymphoid follicles. They are not proprietary or not specific to the tonsil. They look like that in every lymphoid tissue, and so they do look like that in the tonsil as well. So let's see what we have inside. We have the primary follicles and the secondary follicles. So the primary are the denser ones. So we have circles that have clear clearer cells inside, right? Or like they look lighter inside, this one, but there are also some that look dark. So this one looks dark, doesn't have anything clear inside. This would be a primary follicle, and the other one is going to be secondary follicle. Mm, and they are basically dense aggregates of lymphocytes. And the secondary follicles, they have this germinal center, something that is active and proliferates. These are um, B lymphocytes, and they have more cytoplasm. When you look at them, why are they lighter from far away, right? They just have more cytoplasm. And by cytoplasm, I mean everything pinkish around here, whereas the ones surrounding them are just these dark circles, dark nuclei. You don't see the cytoplasm. It doesn't mean they don't have it, but it's just so little that you don't see it on the histology slides, whereas these guys have some more cytoplasm happening inside. And we also have some regions called interfollicular regions, so the regions between follicles. Let's see if there is anything else that I'm supposed to tell you about. No? Okay, and we have participants who'd like to have the notes, of course. So what I'm going to be doing, I'm going to be sharing the notes with you when you comment on this. I don't have a setup yet for you to just show you the link to download, but if you're interested, give me a comment, notes, or that you want to have notes, and I'm going to reach out to you and I'm going to give you the notes on all the 3 organs, on the eye, on the skin, and on the tonsil. And something else I wanted to show you, and that has always been a fantastic conversation starter when I go to conferences, are these earrings that I have. And if you're interested in getting them for yourself or for somebody else, I do have them. They're available, and you can actually scan this QR code. You should see it on the screen, and it's going to take you to the store where you can buy them. We currently have 3 patterns. Let me show you the third one. I have a bunch of them. Well, by bunch, I actually only mean 25 per pattern. This is the 3rd pattern that we have. And you can get, sorry, I want to show me. So if you're interested, if you go to conferences, if you want to show fancy in the lab, or and have people ask you, oh, nice earrings, what is it there? We have ones that are with a multinucleated giant cell. Does it focus on it? This is a multinucleated giant cell, a type of immune cell, macrophage, actually, a bunch of macrophages that come together. We have one with cartilage. Come on. Okay. And we have one that is not unpacked yet with a special stain, Alcyon blue of colonic crypts. So if you want to look different and show what you look at under the microscope, you can get them in our store. The QR code is on the screen. And also, those slides that we were viewing now were possible. I was able to show them to you because of a technology called digital pathology. This is something I have been promoting for the last 10 years. Digital pathology makes us be able to view glass slides to view tissue digitally. So if you're interested in learning more about digital pathology, there is a book I have for you. This book is absolutely free. You can grab it also by scanning this QR code, and then you will learn more about digital pathology. And we're going to be updating this with a new chapter on AI very soon. So if you grab the version that I have available today, you will automatically get the updated version when I'm ready with the updates. If you're watching the replay, let me know in the chat if you have any questions. What would you like to learn more about? And in the future, meaning probably already next week, we will be talking about mouse histology and rat histology. But if you're interested in human histology, don't worry, the tissues look almost the same. Like, you know the histology of a rat liver, you will understand the histology of human liver. So this is totally cross-disciplinary. So if you are a researcher that needs information on animal tissue, that's going to be perfect. But if you just want to brush off or step up your histology game, it doesn't matter the species, because in mammals, these appearances, the tissue appearance translates. And me as a veterinary pathologist, I can totally recognize all the human tissues and actually describe their structures based on what I learned in veterinary histology. So no worries about that. Uh, Thank you so much for joining me. If you're interested in the notes, let me know in the chat. Just put notes, and I'm going to reach out to you with the notes from today's class. Thank you so much, and I talk to you in the next episode.